Start recording. Okay, so we can start. Today I would like to show my new library, SeqProto. I just published it 10 minutes ago, and it used to serialize typically the some objects. So how it works? Let's start with from README. So is a low-level API library that allow you to serialize your object in binary format. So import it, create the serializer, create serialize something, get the buffer, create the serializer from the buffer, and deserialize it. In the end, you have the initial values. Why I developed this? Because it's faster. I mean, really faster. And this is why recently on LinkedIn in particular, I posted a lot of posts on about JSONs and why it is slow. So before starting deep in dive how it works, I would like to show you the result because without number we say nothing. Just a few moments. Benchmark ser test pm run this. So this run the benchmark serializing and deserializing 200 of to do. With to do I mean a list of to do. So four fields, two numbers, one string, another one is boolean with user ID, title, and completed. So the test I'm running is this test. I comment all of other. I decomment it in a while because Avro and my library is not called Cerdes, is the previous one. SeqProto are the fastest one. Try to comment all of them. Okay, so I ran a test with my library, protobuf, Avro, Cyborg, CyborX, MessagePack, MessagePack-ER, and JSON. This is the most common serialization library that I found on the internet, on the posts and so on. If you want to suggest me others, please write a message. I will include it now on the fly. Anyway, write in chat if you like it, if you don't like it, if you don't understand, and so on. Will be a pleasure to answer. So, protobuf is a buffer, is a library that allow you to describe how a object is serialized. You can write a file like that, .proto, that describe your types. For instance, here we have to do message, that is to do repeated objects typed as to do message. This is the way in protobuf you can serialize an array of stuff at the top level, and this is the message, the to do with the three fields. How it works? I load the data from the types from the files, look up the type, and using these typo, oops, proto, okay, here to decode and encode. This is the way you can do that. Avro it's much simpler than protobuf and also most performant because instead of having this kind of file, external file, I can write directly here from a schema. This is not this JSON schema, but remembers a lot it. So you can create a type using this notation. Is very well typed. So here also the TypeScript help you to fill this. And this is the way I put the array of records. This is objects, which fills with user ID as integer, ID as integer, title as string, and complete as boolean. So after that, there's cbar. Cbar is a way. Let me wait. Okay, let me exactly this. This not okay. This is a concise binary object representation. I don't know why this is so familiar because the performance is very bad. There is two implementation, at least in JavaScript, cbar and cbarx. Cbarx is very better, not well, but better. After that, there is a message pack. Also, message pack is a standard way to encode. It's like JSON, but fast and small. There is something like you can map something like that. So you can say, hey, there is two elements in this map, is a 7-byte length, and the value is true. After that, there is 6-byte length of string length with the value 0. And the way you can do is using two libraries, message pack and message pack R. Message pack R is faster than message pack and has a very similar APIs, as you can see. In the end, last but not least, obviously, there is the JSON where I can parse and stringify the values. So this is the structure of this. And what happened if I run it? Let's see together. It takes a while, obviously, because firstly it warm up the CPU, because when you want to test the performance of piece of codes, there is a lot of garbage in your PC that compromise the numbers. I mean, there is some the CPU, the process can move from CPU to another with a context switch and so on. So to avoid this, the framework you are using for benchmarking your code warm up the stuff, the CPU. So you are almost sure, hey, we are almost sure that the process doesn't go in another CPU. Hi, Matteo. We are saying something like how fast we can serialize and deserialize stuff. Here, there is a bunch of library plus my one. I create this library now. Now I mean I publish it 20 minutes ago, and this is a lot performant. There is a question. Hello, sorry for bothering you. I want to offer. No, thanks. Let's see my benchmark. Oh, obviously. So this is the benchmark. So as you can see, this is my library. Faster. Hey, obviously. After that, we have protobuf with this number is half spanometrically. Avro, it's faster, but not so fast. Sibori X is bad performance. Comparing to JSON, JSON is faster. And also message pack is not well good in performance. I mean, not for pointing to is not a bad protocols. Protobuf, Cibor, and message pack, none of them are bad. Actually are good, not for serializing in HTTP API, for example. Protobuf, for instance, is common used with zRPC and so on. So also Avro in Kafka messages is used a lot. Cibor in general and message pack, I never use them, but is always available in the market as a solution, as a valid solution. So could be a very good solution for this. So how this is more or less how it works. No, the benchmark how it works. I would like to show you also the only deserialize part, because I add also fast JSON stringify. Fast JSON stringify comparing to JSON, just the plain JSON, request you to describe a JSON schema. So using the JSON schema, he create a function that serialize that the data described by the schema is used, for example, by Fastify. So wait a second. Here. This is a very good, actually, this is a very good, very good library that allow you to serialize data to string and request to you to have this schema as input. After that, you have a function that help you to serialize to serialize the objects. Let's run also serialize. This benchmark, this actually is almost identical for SerDes, but without this deserialization part. And here, SeqProto is a lot faster than other. Also comparing to Avro, that down is just 10%. Instead, here we have 1.5x, more or less. And the reason is because we will deep dive in a while. So, which tool I use for benchmarking? I'm using Benny. I try Mitrata, probably. I don't remember. But Benny is a very good tool to write benchmark. Is firstly, it's easy to use. So await b dot suite, b dot add, b dot add, and so on. And in the end, I don't care. I copy and paste this. And the function can be sync, async, and he handle for you also the startup. So you can do something like, for instance, I don't know, const to do's return. In this way, you are telling to Benny, this is the startup function. The startup function is not calculated inside the benchmark, obviously, and this is the bench you want to monitor, to want to have measure, and also works with async, something like that, or just like that, or just that, and this is amazing. Uh, and also the result is very stable. Comparing to other GF pairs, benchmark JS, and so on, the number are stable, more or less, obviously, but are not equal among the runs, but are almost stable. So return back to our part, ser benchmark. This is the output. As you can see, oops, not ser this. This is the previous name, SeqProto. I didn't change it yet. Let me, okay. SeqProto. Okay. As you can see, my library go faster a lot of faster, and this is amazing. Why I developed this? Because I requires um, runtime independent. For instance, Avro depends on runtime or browser, uh, and not just on JavaScript types. For example, array buffer, data view, typed array, unsigned integer 32 array, and so on. Performance, as you can see, there is a performance, small size. Let me show you the result. For instance, as Avro.js. Avro.js has this has packet and packet size. Instead, SeqProto is just a few of kilo. And this is amazing when you want to work on, for instance, Cloudflare. I would like to have a library that works on Cloudflare, and Avro, for example, doesn't have these requirements. I don't know if it is work, honestly, but reading the code and reading the README, I discovered, for instance, reading the code, he used the buffer and util from Node.js, and obviously on different runtimes, this is not correct. Small size because, as already said, I needed to work on Cloudflare, so have some limitation. Customizable. I would like to have the completely freedom to serialize my view, my data, and TypeScript support because it's very useful. So how I can write something in serialize and deserialize? We discover a little bit in the benchmark, but starting for simple. This is the way. So I just for starting from my request Boolean. I can serialize Boolean, u int 32, float, string, and array. Generic array, actually. Array of integer, array of objects, array of float, Boolean, and so on. The deserialized part works in the opposite sides. So the first thing I serialize is Boolean, so the first thing I deserialize is Boolean, and after that a integer, a float, a string, an array. So this is more or less how it works, how I can use it. The to-do here is more or less what we already saw. So I can serialize also an array of objects manually, as you can see, completely manually, because this is the base on which I can create, for instance, the I, I can write this code knowing your type through schema, through I don't care. I can write for you this part. So I I am not worried about this is too complex to understand for now, because I can obviously say, hey, I can generate for you, no problem. After the serialization, in the end, I got the buffer, and I can create the serializer from the buffer and serialize the array in the reverse order. Also, the complex object, as you can see here, for example, the post that has a creator, has a user, and a comment, and the comment has the creator of the comment, the user. And this is how I can split my serialization function. For instance, because I serialize user inside the comment but also inside the post, I can reuse the same function serialize user and deserialize user in both places. This is help a lot, obviously, during your serialization process and the serialization process. And that's all. Now you want to see how it works. Actually, the code is just in this file and stop, counting also the types. So more or less what we are talking about is less than 80 line, more or less. And I work on a rebuffer using the float, the well-typed array in JavaScript. Recently, JavaScript array typed array. This is how it works. So basically we have a unsigned integer 80 byte, means that every spot is just 8 bit, so just 1 byte. 60 bit means 2 byte, 32 and 64. This is how the memory works. Rust helped me a lot here because Rust, for instance, serialize own data structure in memory almost in this way. I rearrange the types also to having less defragmentation of the memory as possible, and that's it. Generally, we have just a buffer, a general array buffer. I reuse the same array buffer over different deserialization, so I can reuse the serialization. I pre-allocate a buffer on top of the serialization, and as you can see here, there is the part just unique, because the serialization is a CPU intensive process. I can reuse the same buffer because in the meantime I'm serializing it. Nothing interfere with my buffer. There is no yield, there is no await, there is no something of that, and the CPU is just mine during the serialization. This is how JavaScript works. It's not a shared array buffer, just array buffer, because let's see, shared array buffer. Otherwise, I care if someone write in the meantime I write, because it's shared between workers and so on. In this way, instead, I'm pretty sure this is okay. Okay. How it works? Well, I pre-allocate the buffer. I build two view. This is called view because underline is not a copy of the array, it's just a view. So indexing on this, I'm indexing 4 byte at time. So index 0 is 0, 1, 2, 3. Index 1, 4, 5, 6, 7, and so on. Reading unsigned integer or float 32 bit array. And actually the implementation is very simple, because during the serialization I keep track which is the position I reach during the serialization, and put inside that point the right type, the right value. So serializing my boolean is just 1 or 2, 1 or 0. Could be improved, this part, take a while. Serialize is just like, hey, assign, because you as developer know that that value is unsigned integer 32. For instance, every IDs came from database. Inside the database, the type is unsigned integer 42 or 64. So you know how much the bytes potentially your number takes, and this is good to also use it in this deserialization part, because as you can see in the benchmark, allow you to reach really the moon. The float, instead of using unsigned integer 32, I need to use float 32. And this is the most tricky part, the serialized string, because I don't have the native way to support a string. So I need to use text encode and text encode and decode. If you don't know what those object does, actually encode and decode string in buffer using UTF-8, UTF-8 as encoder, because at least you compact as much as possible your text. It's a bit slower than UTF-16, but we don't care to reach March. So the moon is sufficient for me, is enough. So this is you need to instantiate, give a string and the buffer you want to serialize in. The return value is the number of the element you serialize it. This is not an allocation of memory, but just again a view of the given buffer. So using the same memory, I'm saying text encoder, please encode this string into in this view. This view leverage on the same buffer, but not starting from the 0, but starting from the this index plus 1 per multiply 4. This multiplication is because this index is used to index a 32 array. Instead, here we have an array of 8 bytes. So 32 8 goes 40 times in 32, more or less. So this is more or less how I can move from 32 view to 8 bit view. Index.1 plus 1 is because in the first position I'm going to track how much the string is length. So in this index I store the written byte. This is the written byte. After that, I move my pointer to the at the end of the serialized string, and the serialized part works almost identically, but in the reverse order. So I read the first byte on the first byte the length of the string. So you can use after that the decoder that help you to decode from a given buffer a string. In this case, again, this is not a memory allocation of a memory, but leverage on the same memory, reading a bit per time, and this is again how this multiplication work, because I need to move from 8-bit view into no, from 32 view into 8-byte view, and this is the length of the byte I need to read. I don't know if it is clear or not, let me know. And that's it. Okay, last but not least, the array, serialized array. Actually, I store the length of the array, and after that, I require to the user, to the developer, to give me the serialization, how I can serialize the element, the item of this array, and invoke the function. In the reverse mode, the deserialize, I pre-allocate the array because I know how much object I am expecting to have, and deserialize. This is also well typed in TypeScript, so is good enough also to use. And that's it. If there is some question, please write in the chat. I have here the chat. So no problem at all. I create also a serialized falsify test because posting on LinkedIn, people ask me, hey, how this impacted the developer experience. Depends on your what you mean with developer experience. Developer experience is supported well made by TypeScript, but if you need debugging stuff and so on, this is not like developer experience, but also debugging and so on. So I would like to invoke API, and if that API return to me a bytes, I am not able to read it. So how can invoke this API and let me return something I can read? Question mark. This is the point. Well, we can do something also here. This is the serialized test, Fastify test. I have here the to do, the same to do, 200 of to do, and here there is the API endpoint where I export the plugin. I register slash to do endpoint, and based on the accept header, I use different serialization. Here I not use yet my library, as you can see. I use my library, yes, but linked locally, so sorry. And I can test it, so I can benchmark it using also HTTP request. And well, why not do that? Serialize, specify, pm start. Okay, I need to pm install SeqProto. Okay, I need to change the import. SeqProto. Perfect. H start. Okay. Run dev. Okay. So where is the here? Localhost. Okay. Whoa. Sorry for the blank. So here I have two buttons, get by JSON here, that return to me the common, in a common way, the JSON list. And here I have the binary. As you can see here, there is nothing to preview because the response is octestream with this as content length. Sorry, I'm not good in English number. Instead, the JSON is very high, is higher. So as you can see here, I have the binary that is capable to read actually that part. So how it works? This is the serializer. Actually, I need to move it into dedicated using the my library, the SeqProto library. But more or less the implementation is definitely the same. And here there is not to do, but Cerdes. I don't care. Let's start from this and let's start benching this because soon more or less are the same, not the same because SeqProto, I enhanced SeqProto in a bit, but the most important part is not this, is the benchmark. Start. I run Fastify saying turn off completely the logs, just only error. And let's see if I'm capable to curl accept application/json http localhost todos not todos API. Okay, perfect. This is the output. Okay, so I can use autocannon. Perfect. Let's see how we can do. Okay, this is the number using JSON. So let me use, for instance, this part. I don't want to use Avro, but this library that is implemented the same because have more perform better. Okay. Okay, as you can see, is higher than just merely JSON, but we can do it better. So what happened if I using, let's see what I'm using here to do. This is use my custom library, actually not my custom library, but a copy of my custom library. As BAM. So we reach a lot of requests, a lot. I mean, in this way, we can really, really do a good stuff here. So this is more like why I'm developing this library. I recently also discovered a little bug. We have time? Yes, we have time. So we can do it together if you want. If there is some question, some checks you want to do together, write in the chat. Is not a problem. So, so close all. The issue I discovered recently is during the deserialization process. Deserialization process, this is the file this is more or less the deserialization part, the benchmark of the deserialization part. Is similar to CERDES, obviously, but just just using the deserialization side. And these perform worst. Let's run it. Stop this, we don't care. Test. So meanwhile, we perform in a good way during the serialization. Unfortunately, during the serialization, we are very bad number. Okay, so the reason why my library perform so bad is due to the fact I make a copy. So where I'm set buffer here. This here we make a slice. Slice copy the slice actually copy is a copy. So here actually I'm testing a copy of the a copy of the whole array, and this perform very bad, as you can see. So we can use different equal action, allocate we don't care, copy using slice method. You can efficiently copy a portion of memory without creating new view to manually copy each byte. Yes, efficiently, well, you are always copy a memory, so we can avoid this. Using transfer method, you can transfer ownership of a memory span to a new buffer object. This is useful when transferring data between different execution contexts without copying. After the transfer, the original buffer is not longer usable. A share cannot be transferred. Okay, so what means? Ah, return a new array buffer object. Its content is initialized to the content of array buffer, and extra byte, if any, are filled with 0. Okay, in this case, if the parameter is higher than the value, is not our case. The new array buffer is we don't care. Okay, so perform the same as a cloned algorithm. It copy into a new one. Okay, always a copy. I don't want to copy it. Definitely not. So transfer is not usable. Resize, no. So let's see if buffer array blah 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 constructor slice resize transfer, but also transfer with the same with the it's not clear if it is a copy or not here. Initialize of the content of this array is not clear. Description, yes. Okay, so no. Let's see the constructor. The constructor take the length and the option. No. Okay, but here I can use the constructor of the view. This is the view, so I can use the same trick I used during the string serialization and the serialization, because I can put here the buffer and the offset with the length. Okay, I go for this. So instead of put the slice, just something like that. I need to check if this is correct. I really don't know. Okay. Because the length byte offset is in byte, because a byte offset is in byte. So 0 is byte, it's okay. And a length in which length when called with a non-object. Huh? When called with a non-object, the parameter we treat as number specify the length. An internal array is getting. I don't care. Okay, this length. When called with a rebuffer instance, an option length the byte of in bytes and length in number of element. In number of element. Okay. So this is not n. So more or less is this slash for math.floor, something like that. Because when I created the deserialization, I receive the buffer. The buffer has length in byte. Okay. The length in byte means the length of use unsigned integer 32. So 8, sorry, unsigned integer 8. So just mean 1 byte. 80 to reach 32, I have to divide by 4. Yeah. So and 32 and 32 and 32. Something like that, probably. Let's see, pm test. Yeah, all is green. Green, I mean, this is the test. There is the test from basic, Boolean, unsigned, float, and so on, array, and so on. And after that, I would like to check if in every order I put my items, the deserialization is okay. This is the tricky part. I mean, the deserialization should not be broken if I put, should not work only if I put before, I don't know, the integer after the string and the reverse order doesn't work. So inside the test, in the end of my file here, I calculate all the permutation. So I serialize foo bar 342 0.6 and this number in every possible orders to check if the serialization works correctly. So with this fix, I don't know how we perform now that this part, the serialization part, should be better. I don't know. Let's see. Okay, better. Better, but not enough. Huh. Better, but not enough. Well, better than before. It's okay, but not enough. Okay, let's commit this. Let's see the difference. Okay, renaming, blah blah blah. Okay, fix typo, renaming, remove comment. Okay, so let's remove all comment from this part. This is all okay. This is all okay. Also pian rallint, why not? Wow. No, lint no. I I fix it later. Git commit -m. Use view instead of array buffer copy. Git push. Okay. So this is more like what I want to show you. There is some question. Please write in the chat. Some question. Please feel free really to post what you want. If there is no other question, we don't answer to the main part. Why JSON are so slow? Well, JSON are so slow because this spec are bad. Firstly, the object in the spec, the key of the object can be duplicated by the spec. So I can create an object with two keys with the same value. I don't know, foo and foo. Two key with foo is a valid object. And obviously repeat also the keys. The struct are not well typed, is always an object and structure object, even if you know which is the structure you are serialized. So this is more or less why JSON are bad. So there is no other questions. So thank you for joining. Thank you for watching. Bye.